In this video, we're going to talk about the software called UGENE. So how do you get it? Well, you go to Google, and the easiest way is to simply type in UGENE. Doesn't have to be capital, and you search. And here is the site for it. Now you want to go to downloads. All right, and of course it's going to detect the type of machine you have, and it should tell you for Windows or for Mac. I'm using Linux, so it's telling me that I need to download the Linux version. If you have any issues, when you get to this page, you can just click downloads here, and there we go, and it gives you kind of some basic versions. Probably if you're on Windows, you can do the installer, and that will download a program, and then it will kind of install it for you. Or you can download it as a zip file in case you want to install it again offline, or move it to a different computer or something. You can install the zip, and it still should install relatively simple. You'll have to find the executable and run it within the zip file. But here it will install it for you. If you're using Linux, you go here. A bit more complicated. I don't recommend this. And I have no idea what this does with a Mac. I assume you click on it and it works. I don't know. Now, there are different versions. It's meant for Windows 7 and greater, so this is the same version that you should get up here. This is the installer and the zip. They should be the same. Now, if you are on an older machine, you'd use the 32-bit. I don't think any of you will be, but if you are, and if you're not sure, you can ask me if you're on 32-bit. But if you've bought a computer in the last 10 years, you're probably up here on 64-bit. All right, this is Linux and this is Mac. I don't know that much about Macs, but I know there are different versions and types of Macs. I've used an Intel Mac before, or a Wintel Mac as they call them. This should work for the majority of Macs if you're running on a Mac. If you have any questions, email me and maybe we can Zoom and get this done if you have problems. But you should be able to just download it and install it. Now, the website, like I said, is ugene.net. All right, if you can't see that, it's ugene.net. If you just go there and go to downloads, find downloads to click on, or you can do the /download-all HTML. That will get it, but if you just search for it online, you should be able to find this site. Now let's run it and see what it looks like. So I'm going to run it here, and this is what comes up, and it's a reasonably understandable program. Most of the time you will be doing things like opening files, so you can open a gene. Let's see if they have one. Here's a FASTA file that they just have as default, and you can see what it looks like. It lets you scroll along it, so you can click here and you can scroll. You can scroll up and down like this. You could do it over here too. There are some other features. We don't actually use this too much in this particular way. The tool that we will use more than anything else in this one is the tool. We will do multiple alignments, and the great thing about this one is that it has 6 different types of multiple alignments, different programs, and they're all a little bit different and give you slightly different answers, because the process of alignment is not as straightforward as you would like it to be. It's not perfect, and so you have different programs. They all give you a slightly different answer. We will look at a few of them. Let's see, the thing we're going to use, especially this week, first week or second week now, is build.plot. And what you do, you open build.plot. So what did I do? I went to tools and I dropped down and I went to .plot. And .plot is your #1 tool in this class. And what you will do is you will put a sequence in here. So first sequence. So if you're doing this with the GPX genes, for instance, you would open it and you would go find your first GPX gene that you want to compare to another one, and then you would go find a second one. I'm going to do something. I'm going to compare this one to itself. So I'm putting the same gene in here, and this is something you should do with all of your genes, as you will see in the assignment. to find out where there are repeats. That's a very important thing that you need to do. It can tell you lots of interesting things about your gene just by comparing it to itself using dot plot. So let's go next after I put those in, and here is our screen, and it's telling us which gene is going to be along the x-axis and the y-axis. You'll see what that means in a second. And here you have some buttons to push. Normally you only want direct repeats. Every now and then you might want it inverted, and we will talk about why you might want inverted sometimes. That will be in a different video. All right, and here is your repeat length and identity. Now what this is doing, this is telling us how big of chunks we want to compare at one time, and I will explain that at a later time. For now, when you do this the first time, just go over here to these buttons and click this and click this. Okay, now this is saying we want it to be 100% identical. So when we're going to make little dots wherever the sequence is similar. So whenever we get 12 bases that are identical to the other sequence, we're going to get a dot, and it's going to make a little graph for us, and I'll show you what that looks like. Now here we want 100%, and we're going to create dots with 12 times. So every time we get 12 that are identical, we would do it. Now we can do this differently. I'll go ahead and do a little bit. We'll say we don't want 12, we want 90%. So 90% of 12 is, well, it's still going to be like 11 or 10 or 11 out of 12. So in other words, we're saying we don't mind if there's one or two differences here out of every 12. So it's going to go sliding down the sequence, and it's going to compare the two sequences, and anywhere that it's 90% the same per 12, all right, it's going to put a dot. And so let's look just to get an idea what that would look like. And of course, here's our dot plot. Now I can squeeze here and I can go make it a little bit bigger. And what this means is here is one sequence and here's the other. Now these just happen to be identical. So of course, along the diagonal here, you are going to get a straight line. So a straight line along the diagonal means you have essentially the same sequence, or one that's very similar. This one, it could be a little different because we said 90%. So there are no gaps along here because it is absolutely identical. Now the interesting thing is to look out here, and this fuzziness out here is telling you that there are repetitive elements, especially right here and right here. Let's see, you should get something similar over here somewhere. But it's telling you that there are repetitive places in the sequence where a place here is similar to a place down here. And we'll learn more about this, but this is the kind of thing, this video, we're just kind of learning to install it and how to click on everything. So once you make a dot plot, what do you want to do with it? Well, you're usually going to have to send it to me, and the way to do that is to right click, all right, and to save or load. So save as image, all right, and you name it whatever you want. I prefer JPEGs, but I really don't care what you send it. And you can even include the quality. Sometimes it's not as important to have high quality on these. You can lower it sometimes or increase it depending on what you're doing. Sometimes you want really high quality when you want to zoom in on these little spots here. But when you're just showing me a macro view like this, you can actually lower the quality. So I'll lower the quality. You can also control the height, the width, all kinds of things. And here is your name and where you're going to save it. So I am going to export this to this folder as a JPEG. I changed it. I think it was set up as a PNG at first, but I'm going to export it as a JPEG. And there we go. So now I'm going to go find it. I don't know. I just realized I don't know where the default save is. Let's look at that. It's in Documents, Eugene data. Okay, so yours may or may not be the same as mine. Mine is in Documents and in Eugene data. Yours may or may not save it to the same place. So let's go look at that particular folder. So Documents, and there's Eugene data, and here is our dot plot, and I can click on that, and my image viewer brings it up. And of course I can zoom in on that and look at exactly what I want to look at. Now you could do this within the program. This is just for when you save it and send it to me. Now let's go back to UGENE itself and let's look at some tools. So if I do want to zoom in on something, I can grab a piece, or actually since I did this, look down here what happens. The piece that I'm looking at along here and along here, it shows you both of these, all right, and it highlights, it puts this little dashed line. So if you want to know what the sequence is right along here, or I should say right along here and right along here, because realize the ACGTs, it's kind of like if you had all of the ACGTs here and all the ACTs listed here, and wherever they match, that's what we're getting. We're getting a dot here. And that means when I put this little box on it, the sequences between here and here, they're showing up down here, and I can go look at the sequences. Now it takes some time to figure out, am I looking at this one or am I looking at that one? You can change the controls or whatever, but the top one, let's see, it should tell it, you can hit some of these controls and it'll put labels out here, but I think the top one is along here and the bottom one is back and forth. So it's showing you now, of course, these should be, nope, this is the complement. So nope, I do not have it configured to show both. It's showing just one of these. But that's the idea here, is that you can zoom in. Now a more interesting piece might be this, you know, since this piece looks to be repetitive, which I will explain later, and that might make something kind of interesting. Some of these pieces where they're very similar up close, now I can use the scroll on my mouse and I can zoom in. So, oops, didn't want to do that. And you'll see that there are these things like these little lines nearby. All right, and that's also kind of like sequences that are repetitive. Also, it means that this piece is very similar to this piece, and there's something over here as well. And when you get a lot of these, more complex than this, all right, especially towards the end, it shows you there's a termination signal, and we'll talk about that, how to use UGENE to find a terminator. And it will have to do with looking at it up close like we just did. Like when I scroll in, I'm using my mouse scroll bar. Oh, this is interesting. See, there's lots of stuff going on here. This would be an interesting piece. Maybe this is a splice site, or maybe a terminator, or something along those lines. So keep that in mind. Play around with this, learn to use it. Now there are some other things. If let's say we did it and it doesn't look good, what can we do? What happens if we change some of the parameters? You don't have to restart to change those like 100% or 12 base pair, whatever, 90% that we did. We can actually change the parameters here and it'll pop back up, and we did 12 and 90. What if I made it 50%? So it only had to get half of those. It only had to get 6 out of 12 right. And then we can rerun it. Maybe it's too fuzzy and we want it clearer, and we might reduce we would call a resolution or increase. This would be a decrease, I guess. And we would say, well, I don't want to get 90% or 100%. I only need 50%. Maybe these two organisms are very different, and we still want to find out what parts of the genes or the sequence are related. We could reduce our stringency, that would be the word to use, and see what we get. Well, these of course are identical, so this is going to give us some weird results because they're very much the same. So they're identical. So when we lower this requirement, it's going to look funny. So you don't want what we're about to get here. Too many results. Oh, it was too much for it. Well, what it would have done is it would have made it completely black. It looks like the computer just wasn't up to doing it. And what it would have created, see this black here, it would have just covered the entire screen. So it said, no, computer can't handle this. We aren't going to do it. So there are some limits here. So 50. Let's Let's raise that back up to, oh, let's say 85%, but let's also raise this up to 30, let's make it 35, and then let's see what we get. There we go. So it changed a little bit. You see different things going on, and we will learn to use dot plot in this way to find interesting features. So let's do this again before we end here. I want to add inverted repeats. Now, inverted repeats means that something has been transposed and a piece of DNA has been cut out and then reversed on it's going backwards, or perhaps a piece on the opposite strand has been cut out and moved to the other strand. Both of those will show up as inverted repeats. So we can find places that might have happened by clicking on that inverted repeats, and you'll see we'll get something a little different here. Not too much. I mean, you get a lot of this, but each of these are showing you places where perhaps the strand has been maybe copied, pieces were cut out and duplicated, all right, or they might have been inverted, or they might have come from the other strand. So by including the inverted repeats, you get more marks on here. All right, and we can zoom in and see all these little like pieces that have been chopped out, and notice how repetitive they are. They come in little waves, and that's there is a meaning to that, but it's also an artifact of how the program works. But this is how you use dot plot, and we'll be using it a lot for a couple of weeks. So learn to use it, kind of play with it a little, and it will be our first, we'll have a dot plot lab this week, and I'll make another video on that lab. But you need to watch this one first.